Here we have an elastic collision problem. So we've got a proton with some mass moving at 1.57 kilometers per second. When it collides with the stationary alpha particle of some other mass, we're looking for the velocity of each particle after the collision. So if we analyze what we know, we can start with our givens. And we know that m1, we'll say that's the mass of the proton. So that's equal to 1.67 times 10 to the negative 27 kilograms. So it's an extremely small number. We have the mass of an alpha particle, 6.67, or sorry, 6.64 times 10 to the negative 27 kilograms, so also a very small number. And we know that the mass, or sorry, the velocity of the proton is 1.57 kilometers per second, but we're going to convert that to meters per second. There we go. It's also really important to note that the alpha particle is stationary because that leads us to being able to use a little bit of a shortcut method for solving for either V1 or V2. So there are two shortcut equations here, and this is dependent on what is equal to 0. So in this case, V2 is equal to 0. So we have two really important equations that we've derived that you can use without having to make use of your entire conservation of momentum formula. So the first equation we're going to make use of is V1 primed. So the final velocity of the first object is equal to V1 times m1 minus m2, all divided by your total mass. So again, this only works if V2 is equal to 0, which in this case it is. And there's a different equation to solve for V2 primed. So we can start to substitute values in here. V1 prime is 1,500 meters per second, and that's going to be multiplied by our masses, or sorry, subtracted by the first mass, and multiplied by the first mass minus the second mass. So the first mass, 1.67 times 10 to the negative 27 kilograms, minus 6.64 times 10 to the negative 27 kilograms, all divided by the total mass, m1 plus m2, which I've done quickly is 8.31 times 10 to the negative 27 kilograms. This we can plug in and solve really easily. 940 meters per second. Now the direction is really important here, right? So what this tells us is that it's 940 meters per second backwards, assuming that our initial velocity here was forward. We have a different equation if we're solving for V2. So because V2 is what started off as 0, we have a slightly different equation that we've derived for that. So in this case, V2 prime is equal to 2 times mass 1 times V1 over total mass. So what does this give us here? 2 times mass 1, 1.67 times 10 to the negative 27 kilograms times V1, 1570 meters per second, divided by your total mass, 8.31 times 10 to the negative 27 kilograms. We plug that into a calculator and we'll get 631 meters per second. And of course, that's forward. So there you have it. Again, this is a specific example that only works when V2 is equal to 0.